I'm going to be doing problem number 8. So in this circuit, the battery provides a constant delta V of 50 volts. Capacitor 1 and capacitor 2 are initially uncharged. So the first switch, S1, is closed and it charges this 100 microfarad capacitor. Then switch 1 is opened, which disconnects the battery from the circuit. Following this, S2 is closed. Okay, so for A, the question is, before S2 is closed, what charge is stored on capacitor 1? So before switch 2 is closed, switch 1 is closed, which charges the 100 microfarad capacitor. So what charge is stored on C1, or capacitor 1? So we can figure this out by doing capacitance is equal to charge over delta V, and then we're trying to find the charge, so we do Q is equal to capacitance times delta V. The capacitance is 100 microfarads. The delta V is 50 volts, or the potential difference is 50 volts. And multiply those together, you get 5 times 10 to the negative third coulombs, which is also equal to 5 millicoulombs. So part B is after switch 2 is closed, the potential difference across capacitor 2 is measured to be 35 volts. Delta V here, 35 volts. Determine the capacitance of capacitor 2. So before switch 2 is closed, S1 is opened, which disconnects the battery from the circuit, and then switch 2 is closed. So essentially, we can disregard this entire part of the circuit over here, and the circuit just becomes capacitor 1, this closed switch here, which closes the circuit, and capacitor 2 over here. And capacitor 1 already has a charge on it from when we initially closed this, and it gained a charge over here, and it has this charge, this initial charge. So we can write that here as a given. The initial charge is 5 times 10 to the negative third coulombs. Here we have a potential difference of 35 volts, and it's a closed circuit. So we can find the charge on this plate here on capacitor 2 using the same equation, Q over delta V. Q equals C times delta V, 100. Oh, we're finding the charge on capacitor, so capacitor 1, so we're not going to find the charge for capacitor 2. So we already found the charge on capacitor 1, which is this. And then with 35 volts and 100 microfarads, if there's a 35 volts flowing through the circuit, we can just multiply this. It'll be 3.5 times 10 to the negative third coulombs. So there's a discrepancy between these two numbers, 5 times 10 to the negative third and 3.5 times 10 to the negative third. And all the charge in this circuit should add up. So the charge on capacitor 1 and capacitor 2 should add up to the total charge. The total charge when we started was 5 times 10 to the negative third coulombs. And then right now, capacitor 1 has 3.5 times 10 to the negative third coulombs. And we're trying to find the charge on capacitor 2. So the charge on capacitor 2 is 5 times 10 to the negative third coulombs minus 3.5 times 10 to the negative third coulombs, which is 1.5 times 10 to the negative third coulombs. Then we can go back to this equation to find the capacitance, and we have 1.5 times 10 to the negative third coulombs over 35 volts of potential difference, and that is 4.3 times 10 to the negative fifth farads or approximately 43 microfarad.